Alright, so now let's look at another example using regular polygons. So this one says, find the area of the regular pentagon if the length of the apothem is 6 centimeters. So you can see now we're given the length of the apothem. Remember that the apothem is the length of the segment from the center of the polygon perpendicular to the side of the polygon. So right there I drew in our apothem. And we know that that is 6, okay? Also remember that these regular polygons are actually inscribed within circles. So every vertex of the polygon is actually a point that is on a circle, okay? A circle that circumscribes the pentagon. So here we could fill in those triangles. Remember we were doing that with the last example, right? We have those triangles that we could draw in there with that point of rotation. So if I then recreate this triangle outside of the polygon, so you can kind of see what's happening here. Can I grab that whole thing? Oh, nope. Hold on. Maybe I'll just redraw it outside. Okay. And remember that these triangles are isosceles because this is a radius, right? A radius goes from the center to the point on the circle, which ends up being actually to the vertex. So these radii are congruent all throughout the polygon, the pentagon in this case. So here's my apothem is 6. Okay. Now, what we need to do is consider that measure of the central angle. This angle right here that's created every time the point is rotated around the circle. Okay, so if our circle is 360 degrees and we're rotating it 5 times, we're going to do 360 divided by 5. So that gets me that the measure of each of my central angles is 72 degrees. Oops, I hit a button, sorry. So this is 72 degrees. So if the whole angle of that central angle is 72, we know that the apothem, which is just an altitude, is also an angle bisector. So 72 divided by 2 is 36 degrees. So that angle right there is 36 degrees. Now, just focusing in on that right triangle, where here's my side is 6, and my angle here is 36. If I want the area of the pentagon, there's 5 of these triangles. So I'm going to say 5 times base times height over 2. Instead of having to memorize the formula for area of a regular polygon, I'll just use this, right? So this whole thing is the base, and the height is actually already given as 6, because the height is the apothem. So what I need to do is find this value right there, which would translate to right there on my isosceles triangle. Okay, so what can we do here? We're going to use the tangent, right? So the tangent of 36 is equal to the opposite over the adjacent. So it's 6 times the tangent of 36, which is approximately 4.36. Okay, so that means this is 4.36, and this is also 4.36. So if we do 4.36 and times it by 2, we get 8.72 for my base. Okay, so now let's substitute our values in. Okay, so it's going to be 5 times our base, which is 8.72, our height, which was given to us, is 6, all divided by 2. So 8.72 times 6 divided by 2 and times all that by 5, and we get the area to approximately equal 130.8 centimeters squared. A lot easier for this example when given the apothem versus when given the radius, but definitely know how to do both types of problems.